Welcome to our deep dive into arrays. Arrays are fundamental building blocks in programming, especially in languages like Java. In this video, we'll explore what arrays are, why they're so important, and how they help us manage memory efficiently. Whether you're new to programming or brushing up for exams, understanding arrays will make your coding journey smoother. We'll cover both single and double-dimensional arrays, their features, and practical examples. So let's get started and unlock the power of arrays together. Array is a sequence of variables that all share the same data type. Think of it as a row of lockers, each holding a value, and each locker is identified by a unique number called an index. Arrays help us organize and store data efficiently, making it easier to manage large amounts of information. Once you declare the size of an array, it's fixed and the index always starts at 0. Arrays can represent lists of numbers, names, or any other data type you need to store in bulk. Arrays come with several key features that make them powerful tools in programming. First, arrays are objects, which means they can even hold references to other objects. They're created during runtime and are dynamic, meaning they're stored on the heap. However, once you set their length, it remains fixed throughout the program. These features make arrays both flexible and efficient for handling large datasets or repetitive tasks. Imagine you need to store 20 integers in your program. You could create 20 separate variables, but that would be messy and confusing. Instead, you can use an array to store all 20 numbers under a single variable name, each accessed by its index. This not only keeps your code clean and organized, but also makes it easier to perform operations like searching or sorting. Arrays are essential for efficient memory management and simpler code. Arrays come in two main types, single-dimensional and double-dimensional. Single-dimensional arrays are like a straight line of data, while double-dimensional arrays are more like a table with rows and columns. Each type serves different purposes, and understanding when to use each will help you solve a variety of programming problems efficiently. Single-dimensional array is the simplest form of an array. It's like a single row of data where each element is accessed by one index. For example, int a equals new int 10 creates an integer array of size 10. Each element in the array can be accessed using its index, starting from 0 up to 9. This structure is perfect for storing lists of numbers, names, or any sequence of data. Let's break down the syntax for creating an array. For example, int a equals new int 10 means you're creating an integer array named a with 10 elements. Each element is accessed using a0, a1, and so on. This makes it easy to store and retrieve values without creating multiple variables. Arrays can be created for different data types such as int, float, char, or string depending on what you need to store. Picture an array as a row of boxes, each labeled with a number starting from 0. For example, if you have int a equals new int 10, you get 10 boxes a0, a1, a9. You can store values like 12, 22, 33, and so on in each box. The index inside the brackets helps you identify and access each value quickly and efficiently. Arrays aren't limited to just integers. You can create arrays for floats, characters, and even strings. For example, float f equals new float 10 stores decimal numbers, char c equals new char 10 stores characters, and string s equals new string 10 stores words or names. This flexibility allows you to handle different types of data efficiently in your programs. You can initialize an array by directly providing its values. For example, int I equals 12,345,678,910 instantly fills the array with these numbers. Similarly, char ch equals a BCD creates a character array, and float f equals 1020304050 creates a float array. This method is quick and doesn't require you to specify the size, as it's determined by the number of values you provide. When you initialize an array with values, you don't need to declare its size. The compiler automatically counts the number of values and allocates the right amount of memory. This makes initialization faster and reduces the risk of errors. However, if you're taking input from a user, you'll need to specify the size so the program knows how much space to reserve. In Java, arrays have a special property called length. It tells you how many elements are in the array. For example, int n equals a length gives you the size of the array. Remember, length is not a function, so you don't use parentheses. This is different from the length function used with strings. Using length helps you write flexible code that works with arrays of any size. Let's look at a quick example. If you have int a equals new int 10, then int n equals a length will set n to 10. Similarly, for string s equals Ankita, Guria, Porna, int n equals s length will set n to 3. This makes it easy to loop through arrays without hardcoding their size, making your programs more adaptable. To fill an array with user input, you typically use a loop. For example, you can prompt the user to enter 10 numbers, then use a for loop to store each number in the array. This approach is efficient and ensures that every element is filled correctly. Loops and arrays go hand in hand for handling repetitive tasks in programming. Once you've filled an array, you can display its contents using another loop. For example, a for loop can print each element one by one. This is a common pattern in programming. Use one loop to input data and another to output it. Arrays make it easy to process and display large sets of data efficiently. Arrays support several basic operations, including searching, sorting, merging, insertion, and deletion. These operations are essential for manipulating data in your programs. Mastering these will help you solve a wide range of problems, from finding a specific value to organizing data in a particular order. Searching is one of the most common operations performed on arrays. It involves checking whether a specific value exists in the array. There are two main methods, linear search and binary search. Linear search is straightforward and checks each element one by one, while binary search is faster but requires the array to be sorted. Linear search, also known as sequential search, is the simplest way to find a value in an array. You start at the first element and check each one until you find the target value or reach the end of the array. While it's easy to implement, linear search can be slow for large arrays because it checks every element. Let's say you have an array of 10 integers and you want to check if the number 30 is present. With linear search, you start at index 0 and compare each element to 30. If you find it, you stop and report success. If you reach the end without finding it, you know the number isn't in the array. This method is reliable but not the fastest for large datasets. Binary search is a faster way to find values in a sorted array. Instead of checking every element, it repeatedly divides the array in half, narrowing down the possible location of the target value. This method is much more efficient, but it only works if the array is already sorted. Sorting is another fundamental operation. It involves arranging the elements of an array in a specific order, such as ascending or descending. Sorting makes searching and other operations more efficient. There are many algorithms for sorting like bubble sort, selection sort, and quicksort, each with its own advantages. Merging combines two or more arrays into a single array. This is useful when you need to process data from multiple sources or combine results. Merging can be as simple as appending one array to another, or more complex if you need to maintain a specific order. Insertion means adding a new element to an array. Since arrays have a fixed size, you often need to create a new array with extra space, copy the old elements, and insert the new value at the desired position. This operation can be time-consuming, especially for large arrays. Deleting an element from an array involves removing the value at a specific index and shifting the remaining elements to fill the gap. Like insertion, deletion can be slow for large arrays because it requires moving many elements. Understanding these limitations helps you choose the right data structure for your needs. Double-dimensional arrays, or 2D arrays, are like tables with rows and columns. They're perfect for representing matrices, grids, or any data that needs two levels of organization. In Java, you declare them as int a equals new int34, which creates a table with 3 rows and 4 columns. Each element is accessed using 2 indices, one for the row and one for the column. To create a double-dimensional array in Java, use syntax like int matrix equals new int34. This sets up a grid with 3 rows and 4 columns. You can store data in each cell using matrix row column. 2D arrays are widely used in games, spreadsheets, and scientific calculations. Each element in a 2D array is accessed using 2 indices. For example, matrix 1, 2 refers to the element in the second row and third column. This makes it easy to organize and retrieve data in a structured format, just like reading values from a table. You can initialize a 2D array by providing values in a nested format. For example, int matrix equals 123, 456, 789 creates a 3x3 matrix. Each inner set of braces represents a row. This method is quick and ensures your array is filled with the right data from the start. To process all elements in a 2D array, you use nested loops. The outer loop goes through each row and the inner loop goes through each column. This approach lets you access every cell in the matrix efficiently, making it easy to perform calculations or display the data. Arrays are used everywhere in programming. From storing lists of names to representing game boards or handling large datasets, arrays provide a simple and efficient way to manage data. Their versatility makes them a must-know concept for any programmer. Arrays offer several advantages. They provide fast access to elements, efficient memory usage, and easy data management. With arrays, you can process large amounts of data quickly and write cleaner, more organized code. These benefits make arrays a go-to choice for many programming tasks. Despite their strengths, arrays have some limitations. Their size is fixed once declared, which means you can't easily add or remove elements. Operations like insertion and deletion can be slow, especially for large arrays. Understanding these limitations helps you decide when to use arrays or consider other data structures. When you need more flexibility, consider using other data structures like array lists or linked lists. These structures allow dynamic resizing and make insertion and deletion easier. However, arrays remain the best choice for situations where you need fast, indexed access and know the size in advance. A common mistake is trying to access an index outside the array's bounds, which causes errors. Always ensure your loops and access patterns stay within 0 and array length 1. Another pitfall is confusing the length property with the length function used for strings. Keeping these details in mind will help you avoid bugs. To get the most out of arrays, always initialize them properly, use loops for input and output, and check boundaries before accessing elements. Write clear, readable code and comment your logic when working with complex array operations. These habits will make your programs more reliable and easier to maintain. Arrays aren't just for programming, they mirror real-life scenarios. Think of a row of seats in a theater, a list of students in a class, or a table of scores in a game. Arrays help us model and solve these everyday problems in code, making them a powerful tool for both learning and real-world applications. Let's quickly review what we've learned. Arrays are sequences of variables with the same data type accessed by index. They can be single or double-dimensional and support operations like searching, sorting, and merging. Arrays are efficient but have fixed size, so choose them wisely based on your needs. Ready to test your understanding? Try answering these questions. What is the index of the first element in an array? How do you initialize an array with values? What's the difference between length and length? Practicing these concepts will help you master arrays and use them confidently in your programs. Arrays are a cornerstone of programming, offering a simple yet powerful way to store and manage data. By mastering arrays, you'll be able to write more efficient, organized, and scalable code. Remember to use arrays when you need fast access and know the size of your data in advance. The best way to learn arrays is by practicing. Try writing programs that use arrays for different tasks like storing user input, sorting numbers, or searching for values. The more you practice, the more comfortable you'll become with arrays and their operations. Arrays are a favorite topic in exams, especially in ICSE and other board exams. Make sure you understand how to declare, initialize, and manipulate arrays, as well as perform basic operations like searching and sorting. Practicing past exam questions will give you an edge. There are plenty of resources available to help you master arrays. Check out textbooks, online tutorials, and coding platforms for exercises and examples. Don't hesitate to ask questions in forums or study groups if you get stuck. Learning is easier when you have support. Arrays are a popular topic in programming interviews. Be prepared to answer questions about array operations, searching and sorting algorithms, and real-world applications. Practicing these questions will boost your confidence and help you perform better in interviews. Always remember to plan your array size carefully, use loops for efficient processing, and check for errors like out-of-bounds access. Arrays are powerful, but only when used correctly. With practice and attention to detail, you'll be able to handle any array-related challenge with ease. Congratulations, you've completed a comprehensive overview of arrays. Keep practicing and exploring more advanced topics like multidimensional arrays and array algorithms. Remember, every great programmer started with the basics, so keep learning, stay curious, and happy coding.